So next we're going to look at an example of solving an equation by completing the square. Okay, so let's say we have the equation x squared plus 4x equals 21. Now, normally people will try to subtract the 21 from both sides and set this equation equal to 0 and then try to solve by factoring. But the completing the square method is asking us to do something completely different. So remember your standard form of a quadratic equation is ax squared plus bx plus c. So kind of in this form, I just have my c term on the other side of my equal sign, but my a is the coefficient of x squared, and here it's 1. And my b term here is 4, so b equals 4. And when you do this method, a has to be 1. So I can't use this if I have any number here in front of x squared as a coefficient other than 1. But I have 1 as my coefficient, so I'm good to go ahead and do my completing the square. And when you do that, you're going to take b, divide it in half, and then square it. Okay, so b here is 4. Need to divide that in half and then square it. Simplifying the inside of the parentheses, we know 4 divided by 2 is 2, and 2 squared is 4. Okay, so this is all of the work for completing the square. My 4, after I've squared it, this is what I add to both sides of my equation. This is going to be my factor. Okay. So, if I'm going to add this in to both sides, now I've got x squared plus 4x plus 4 equals 21 plus 4. I have to do it to both sides of the equation. That way everything stays equal. So on my left-hand side, the entire point of completing the square was to make this right here a perfect square trinomial, and it's going to factor as this. So I've got x plus 2 equals 25. Okay, so the number before squaring is the number that's going into your parentheses. The number after squaring is being added to the equation on both sides. Okay, so my factors are the same here, so I can rewrite it as 1 equals 25. And now, instead of setting everything equal to 0 and trying to solve that way, I have something squared equals something else, so I can use the square root method. So that means I need to put a square root on both sides of my equation. X plus 2 squared equals, don't forget, plus or minus the square root of 25. So my radical here gets rid of my exponent, and I'm left with x plus 2 on the left-hand side equals plus or minus, and I know the square root of 25. The square root of 25 is just 5. So I've got x plus 2 equals plus or minus 5. So let's go ahead and break this up into two different equations. I've got x plus 2 equals positive 5, and x plus 2 equals negative 5. And now I can continue solving for x. I need to subtract 2 from both sides in both equations. So this cancels out here, and I got x equals 3. This cancels out here, and I get x equals -7. And we're done.